Hello everyone, welcome to this fifth episode. Today we are looking at seed 85, our fourth confirmed E8 projections, and the one that broke the pattern we thought we had found. Like seed 3, this is a breadth seed, 156 out of 160 circuit sites, which is about 97.5%, fall within 11 kilometers of an E8 edge. That's actually the highest coverage of any projections we have tested, better than seed 3, which was 96.3%, 96.9%. But look at where this lattice is centered. Latitude 75 degrees south, longitude 75 degrees west. That's deep in the Antarctic, near the Ellsworth Mountains. So the previous three seeds all anchored in the northern hemisphere or near the equator. Seed 85 anchors at the opposite end of the Earth and still captures nearly every circuit site on the planet within 11 kilometers of its edge network. So the probability of achieving this by chance, after giving the null model full freedom to optimize its own orientation, is less than 1 in 100. Confirmed with 1,000 independent trials. So the effect size is 2.7 standard deviations. And to put it in context, seed 3's breadth threshold has a p-value of 0.005. Seed 85's is 0.009. So both survive Bonferroni corrections for the 5 thresholds we test, and both are robust. As you can see here, the network of 6,720 edges. It's a massive web and very difficult to see what's really going on. So we're looking at the next layer, supported edges. Edges within 0.1 degrees of a circuit sites, which is about 11 kilometers. So now we are filtering to just the edges that pass within that threshold of a circuit site, and out of 6,720 edges in the full lattice, these are the ones doing the work, the scaffolding that the site sits on. The pattern is familiar. If you've seen seed 3, dense coverage across every continent. The Great Pyramid, Machu Picchu, Angkor Wat, Uluru, Stonehenge, so all within that tolerance, and only 4 sites out of 160 missed the 11 kilometer threshold entirely. So what makes seed 85 interesting is not the individual site placements. At this tolerance, breadth seeds tend to catch almost everything. What makes it interesting is the comparison with the first seed 3. So there are 2 completely different projections of the same crystal. Different seeds generating different sets of 240 vertices and 6,720 edges. We have different anchor points on opposite sides of the planets, yet both achieve the same result, near total coverage at the same distance scale. So as you can see in this map, we have thicker lines, which are lines who share 2 sites or more simultaneously, and we have thinner lines, which is close to only 1 circuit site. So now if we compare the 4 confirmed seeds side by side, seed 3 covers 96.9% of sites within 11 kilometers. Seed 85 covers 97.5% within 11 kilometers. Seed 48 covers 83.1% within 5.6 kilometers, and seed 46 covers only 48.1%, less than half, within 2.2 kilometers, but it's very precise. So we have three completely different signatures across three different distant bands. Each seed excels where the other don't, and that pattern, complementary signatures rather than overlapping ones, is extremely difficult to produce by chance. So now we are filtering another layer, and we're looking only at the edges, thicker edges, which share two sacred sites or more simultaneously. We're looking at the Great Pyramid of Gizeh. So it shares the same line with Mount of Olives, and then if we go further, it also shares with Tak et Soleiman. So that's interesting, and there's quite a few of those lines in these particular projections. So in the last video, I showed you something unexpected. And I told you seeds 3, 48, and 46 all optimize at bearing 250 degrees, the same rotational angle around Earth's polar axis. I said the probability was roughly 1 in 1,300, and that we would test more seeds to see if it held. We did. We tested 270 projections, and the answer is it didn't hold. Seed 85's optimal bearing is 280 degrees, not 250. And our fifth seeds 166, which came close but didn't survive multiple testing corrections, optimize at 140 degrees. So it's completely different. So now I'm going to show you a figure, an image, which shows some interesting information about the distributions, the bearing distributions across the shortlisted seeds we have analyzed. So let's have a look at this. Here we are. This is the bearing distribution across all 270 tested projections. Each bar shows how many shortlisted seeds optimized at each 10-degree bearing bin. If 250 degrees were genuinely preferred, you would see a clear spike at 250 degrees. Instead, the distribution is pretty much flat, and the chi-square test gives a p-value of 0.71, which is perfectly consistent with uniform randomness. And the Rayleigh test for circular uniformity gives a p-value of 0.2, which tells us there is no preferred direction at all. So what happened is a classic statistical lesson with 20 seeds, 3 hitting 250 degrees looked striking. With 40 seeds and 5 hits, it looked even stronger. But from seed 90 onward and across 180 more seeds, not a single additional projections preferred 250 degrees. So the rate dropped from 15% here, as you can see on the graph, to 5.6%, approaching to the 2.8% you will expect by chance. So the early clustering was coincidence amplified by a small sample size. I want to be explicit about this. In the last video, in the seed 46 video, I presented bearing 250 degrees as suggestive and said we will let the data decide. The data decided there is no preferred bearing. The E8 lattice doesn't have a preferred twist relative to Earth's spin axis. That's a null result, and null results matter. They tell us what the geometry isn't, which is just as important as what it is. So what the geometry is, 4 independent projections anchor at different locations with different bearings, each finding statistically significant alignment with the same set of 160 circuit sites across the same planet. So the signal doesn't depend on a specific orientation. It's embedded in a relationship between E8's edge topology and the spatial distributions of these sites. So now I'm going to show you a second figure, which I call the share edge network. So finally, we're looking at the site pair network, and this is showing which pairs of circuit sites share a nearby E8 edge across multiple confirmed seeds. So when two sites are connected by an E8 edge, in not just one projection, but 2 or 3 independently, that's a structural connection. There's a hint of structure. So the lattice geometry keeps linking those same sites, regardless of how you angle the crystal. Some pairs recur. We have Uluru and Katajuta, the Easter Island cluster, which is here. See if I can zoom. I can zoom this in. So we have the Easter Island cluster just here, a triangle, and we have the thickness of those lines quite big here, because they are recurring across the 4 seeds we've just analyzed, 48, seed 3, 46, and 85. Those sites appear regularly, and then there's also St. George Island, Bermuda, Somerset Island, Bermuda here. Mount of Olives and Great Pyramid of Giza appears regularly as well. Some of the sites are not appearing as much. Some appear at one seed, obviously 2 seeds, maybe 3 seeds, but the strongest is the Easter Islands sites for some reason. The Easter Island cluster, Glastonbury and its neighbors as well. Let's have a look at Glastonbury and its neighbors. Well, yes, Shaftesbury and Glastonbury Toll, those 2 sites appear regularly as well. So these are not statistically significant on their own. The sample is too small for formal claims, because I only analyzed 270 projections. Okay, it's very little, but they are worth tracking as we continue the analysis. 4 projections, 270 tested, 4 survived every statistical test, each one different seed, different anchor point, different bearing, different signature, but together they tell us a consistent story. The E8 lattice has something to say about where sacred sites sit on this planet, not from one angle, from multiple independent angles, and the analysis is far from over. So yeah, the E8 lattice is very rich. It has a lot to share, and it has a lot to there's a lot more to be discovered within this 8-dimensional structure. And we've looked at we looked at 270 tested projections, and it has already given us some very important information, but it's also a small sample size, which means we probably need more analysis and more seeds projections to have a formal claim about the behavior of the lattice what kind of metrics we could rely on to tell which E8 lattice could be highly significant in terms of alignment with this particular data set. And again, it's only one data set. There's many data sets we could analyze against the E8 lattice. So that's it for now, for today, and I will be coming with more information with further analysis, but let's sit with this for now because there's a lot to digest. And thank you for watching, and see you for the next episode. Thank you. Bye for now.